discussing related rates. Now, this problem is a related rates problem. And when we're discussing rates, that means that we're discussing differentiation. So the problem given is air is being pumped into a spherical balloon at a rate of 4.5 cubic feet per minute. So we're supposed to find the rate of change of the radius when the radius is 2 feet, given this diagram. So we have to start with the given first, with the given volume, E equals volume, which is increasing at a rate of 4.5 cubic feet per minute. Okay, and then also along with the given, we have a radius of 2 feet. And then we rewrite that so that we can differentiate in respect to the radius. And rewrite it with 9 over 2 because of the given 4.5 cubic feet. Alright. So, now who can tell me the volume of a sphere?
Sure, I can. In order to find the rate of the change of the radius, we must find an equation that relates the radius to the volume, which will look like this. Volume equals 4 over 3 pi radius cubed. Here, why don't you take care of the next step?
Sure. So we need to differentiate the equation for volume of a sphere using implicit differentiation to solve for the change in radius. So we have dv over dt. To do this, we must begin using power rule. So you bring the exponent 3 to the front of the equation and then subtract the exponent minus 1, like this. And then since it's implicit differentiation, we're solving the derivative in respect to the radius in respect to time.
Yeah.
After this, we simplify. Now we need to get dr over dt by itself, so we have to isolate this by dividing both sides by 4 pi radius squared. And then after simplifying, dr over dt equals 1 over 4 pi radius squared dv over dt. And here we have dr over dt isolated. Who would like to come up and solve the rest of the equation?
I would. So basically now, what we're going to be looking for is our dr over dt with the given values that we have to substitute them into the equation. So the first one that we have to substitute is in our radius. And our radius is 2, so we have to substitute that into 1 over 4 pi r squared dv over dt. So when we substitute it in, we're going to multiply it to the 4. Which 2 squared is 4, so once we multiply it to 4, it will be 1 over 16 pi dv over dt. So now our dr over dt is 1 over 16 pi dv over dt. So now we're not finished yet. We still have to substitute in our dv over dt, which is 9 over 2. And then we just finish multiplying it. And since it's looking for it in feet per minute, it would be as, and this would be our final answer.
Okay, so in this example, the volume is increasing at a constant rate. However, the radius is increasing at a variable rate. And just because two rates are increasing, or they're related, it doesn't necessarily mean that they're proportional. In this particular example, the radius is growing more and more slowly as time passes.
Thanks for watching!